Welcome back, everybody. This is Mark Anderson for Kellogg Community College, and today we are going to look at two more problems on the review for the p-tests. And let's actually take a look at this one, which has a sample that's a little smaller than normal. This is a U.S. survey of a city. Find that the average commute time one way is 25 minutes. Now, by doing a small sample of 15 commuters, the city commissioner found that the mean was 27.5 minutes with a standard deviation of 5.5 minutes. So with a 5% alpha, or being 95% certain, can the commissioner conclude that 25 minutes is right? So what this means is that the null hypothesis for step one here, the null hypothesis is to say that, hey, the average commute time is 25 minutes, nobody has a problem here. Now, the alternative is saying, no, we're trying to see if the commissioner is right. So this is a two-tail problem. So we're trying to see if the mu is not 25, so this is a two-tail problem. So we're going to note that in step two, this happens to be a t-test. And the reason why that's important is because we have, less than 30 on our sample size, and we're going to default that to the t-table. So we're going to subtract the 27.5, because that was our x bar, minus our mu, which is 25, divided by our standard deviation, which is 5.5, divided by the square root of the sample size, which is 15. If we compute that, we get 1.760. Now you're going to really want to thank yourself for going this far, because when we go to our chart, in this case we have to go to the t-chart, we're going to look at a couple things here. One thing to note is that in step 3 of this problem here, to do some evaluation, we should note that we have an n of 15. And that also means we have 14 degrees of freedom, because degrees of freedom is always determined by n minus 1. So we're going to go back here to our t-chart, and I'm going to draw on the screen here and take a look at 14 degrees of freedom, and I'll make a little box here to indicate that. Now remember that our target value was 1.760, so that means I am right here in this kind of oval. I'm going to ride the rail up this middle part right here, and I want to ride it up the middle here because I want to show you that this here, this yellow highlighted segment, is where I am going to be, because I'm 1.760, so I'm between here and here. And luckily we have a two-tail test, so that puts me between 10% and 20%. So it looks like my data, going back to the other page here, it looks like my data for the evaluation was, pretty like, it wasn't, right on 50%, but this was between 5 and 10%. So you were between 10, not 5 and 10, 10 and 20%. And since we're between 10 and 20%, our conclusion is that our percentage, being between 10 and 20%, is going to be greater than the alpha of 5%, so we will not reject the null hypothesis. So the city commissioner, even though he found that the average was a little bit higher than 25, and the standard deviation went above and below that 25 if you add 5.5 and subtract 5.5, we're still not going to reject the null hypothesis that the one-way commute is 25 minutes. So this was a real good problem from the fact that your 1.760, if you didn't round that correctly, you might have ended up, maybe on the wrong side of this 1.761. So you had to be on the left side between the 1.345 and 1.761 instead of on the right side. So that's something you may want to consider when you do problems like these. So for our last one, we're going to be taking a look at some fictitious data that I just kind of made up. I just thought it'd be maybe a clever problem here to do an ACT comparison in Ohio versus the national average. So let's just assume that Ohio did a random survey of 100 people and found that their average score was 20.5 and the standard deviation was 3.5. The national average was 20 with a standard deviation of 3. The sample size was much bigger here. Now, we're just basically concluding that is Ohio different than the national average. So this is going to be a two-tailed test because we're just looking for difference. We're not saying better or worse, we're saying different. So in step 1, the null and the alternative is going to have its argument. The null is going to say the average of Ohio is the same as the national, and the alternative is to say, no, these guys are not the same. So that means in step 2, we need to do the formula that corresponds to the two independent samples. So this 20.5, I'm going to take the Ohio and subtract the national. And we always then have mu1 minus mu sub 2, which are ostensibly the same, so that would make 0. And sometimes we put in our answer key a minus 0, just to show that we had a mu1 minus mu2, and ostensibly they would be the same, so we're going to treat those as 0. So then we're going to take the big old square root here. We're going to take 3.5 squared, divided by 1,000, or excuse me, divided by 100. Sorry, that was the Ohio. And then we take our 3 squared and divide it by 1,000. If we do this correctly, we get an answer of 1.38. And I should then note that this is a z-score because these sample sizes were above 30. So now I'm going to go to my z-chart. And if I go to my z-chart, I'm going to look up 1.38, and I will find that 1.38 is 1.3 there. The 8 is 9.162. That was my 1.38 at 9.162. Alright, so let me write that down here, back with my pen. So the decimal is 0.9162. So step 3 is going to be to look at that chart and get that value, which we did. And now since we see that 0.9162 is greater than 50%, I'm going to find the complement. But I also need to double it. I need to double this because this is a two-tailed test. So this 91% is, the complement is 8.38%, but then I need to double it, and that will give me an answer for my step 4, which is 16.76%. And 16.76% is much bigger than my alpha of 5%. So what we're going to say for our step 5, since 16.76% is greater than 5%, we will reject the null hypothesis. Now, you've seen now 3, we will not reject. Oh, almost screwed that up here. We will not reject the null hypothesis. Now you've seen 3 of these problems that all did not reject the null hypothesis. This doesn't mean that p-tests are always, well, we didn't reject the null hypothesis, but this is to show you that you have these situations come up, and it's true that most of your homework did have you reject the null hypothesis, but you can have a pretty good string of those not rejecting the null hypothesis. So thank you for watching and learning a little bit more about these p-tests. You'll have some more of these on this final exam, and you'll also have the other z's and t's that we've been prepping you for as well. So thank you for watching. I appreciate it.